Hey everybody, we are talking about ellipses today, and basically an ellipse is kind of like a big oval, okay? So this is the shape approximately of an ellipse, okay? And basically what an ellipse is it's the set of all points, we'll call them P, so here's one of the points is P, such that the sum of the distances between P and two foci, which these are the two foci in here, foci, that the sum of their distances is constant. And so we know that this is right here the distance 1 and this is distance 2. So as the point goes around the circle, the distances from one foci to the other always add the same. Okay? So when we're looking at these ellipse, pretend like I drew a perfect oval, but these are the ellipse. There are two foci, and that's what we're looking at here, okay? There are two vertices, and vertices are like the points on the end across the longest length. So we know that this is longer horizontally than vertically. So this is a vertical, or excuse me, a vertice, and this is also a vertice, okay? The major axis runs through both the vertices and the foci. So the major axis is right here. And if this is the center, so I'm going to put that in pink, we'll call that the center, we'll call that point H comma K. The distance from the center to each vertice is what we call a distance of A. So we call this right here A, which is why the total major axis is 2 times A long. So the whole axis is from vertice to vertice, but half the distance is just this value for A. Then we have two co-vertices, and they run the other way. They run opposite the major axes. So here's the center, so it's going to go right on top and right on bottom, and that's the co-vertice. Okay, and then the minor axis runs between the two of them and the center. And this distance from here to here, we call that's B. So that's where we get the 2B from. So hopefully that you've got that written down and committed to your brain. You need to know all of those parts, okay? Couple more things that you need to know. Oh, also the other thing you need to know is that C squared, which the distance of C is between the center and the foci, is right here. So C squared equals A squared plus B squared. So it's the measure of half of the major axis squared plus measure of half of the minor axis squared equals the distance from the center to the foci squared. Okay? So I should say there are two. Then the foci are the distance C from the center along the major axis. All right, so let's talk about these two kinds of ellipses. So there's a horizontal ellipse. I call this like the hamburger ellipse. You ever in elementary school, maybe your teacher said, okay, fold your piece of paper and should say either hamburger or hot dog. This is the hamburger ellipse because it's kind of wider and shorter, right? And I call the vertical ellipse the hot dog burger or the hot dog ellipse because it looks taller and skinnier, okay? So remember that our center here is H comma K. And again, on the major axis, that's the longest axis, that is our A axis. So from here to here to the center, that's our value for A, which is why this point is A, and from here to here is also A. This is our vertice. So in this case, if the center is 0, 0, the vertice is negative A comma 0 and A comma 0. And then along here is our minor axis right here. The distance from 0 to B is B, and the distance from 0 to negative B is also B. So our co-vertices, if the center is at 0, would be 0 comma B and 0 comma negative B. And then keep in mind, once you find the value of C, it's going to go here, where these are your foci, where these are their values of C. Okay, and same thing here. If here is your center of H comma K, your major axes, right? Your major axis is going to be the longest axis. So this distance from here to here is A. This distance from here to here is A. This distance on the minor axes is B. That's why we labeled this B, because it's B units long. And then again, if we find the focus, the distance is on the major axis. So we'll call this distance C. And that's your foci point. Keep in mind, again, A is half the major axis, B is half the minor axis. And in order to find the foci, we use C equals A squared plus B squared. Also, A is always greater than B. So that means, because when we're talking about this, we're not going to be looking at A and B. We're just going to be looking at numbers. If the value for A is always bigger than B, then that's how we know what the major axis is. Notice how that the A value here is under the X. Do you see how the major axis is the longest axis, which is along the X axis there? Same thing with here. A in this case is under the Y, which tells me that the major axis, the longest axis, is on the Y or vertical direction. Okay, so keep that in mind as well, that A is always greater than B, and it indicates which one is the major axis. Okay, so let's talk about this. Graph the ellipse given by y squared plus 25 squared equals 100. Identify the vertices, co-vertices, and the foci. Okay, so we know vertices are on the major axis, co-vertices are on the minor axis, and foci are along the major axis as well. So a couple of things. I can't tell which one this is yet because it doesn't look at all the way that either of these ellipse formulas look. Now, first of all, the thing I'm looking for is it has to equal 1 here for either of these. Notice how this is 100. I cannot have it stay 100. So what I'm going to do is I'm going to divide the 100 to everything, and this will cancel out to a 1, which is beautiful. That's what I want it to be. Now, this 100 goes here, and it goes here. So 4x squared over 100 plus 25y squared over 100. Now we're going to simplify the denominator. 4 and 10 reduced to 25. And 25 over 10 reduced to 4 in the denominator. So we're left with x squared over 25 plus y squared over 4 equals 1. This is an equation for an ellipse. Now, let's look. Which denominator is bigger? I see that the denominator is bigger on the x. So this tells me that our a squared is 25. So that means our a value is 5. That's our major axis. And it's lying under the x value, which tells me that this is going to be a horizontal ellipse, or the hamburger ellipse that we were talking about. We also know by looking at this ellipse that the h comma k are 0, 0 because there's nothing on the x. So you could think about this as x minus 0 squared over 25 plus y minus 0 squared over 4 equals 1. That tells me that the center is at 0, 0. So I'm going to draw that first. Now I know that if A is 5 on the x-axis, I'm going to go from the center and count 5. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 to the left. These are my vertices along my major axis. Okay, from there, now I'm going to look here at my minor axis. I know this is along the y, and this is going to give my co-vertices, but here's what I know. I know 4 equals b squared. So if I take root of both sides, I get b equals 4. That's the length of half of the minor axis from the vertex or the center. So from the center, I'm going to go up 4, 1, 2, 3, 4, and down 1, 2, 3, 4 as well. And these points here are my co-vertices. Okay, now once I've got my vertices and co-vertices, that is my ellipse. Let's see if I can draw it so it doesn't look terrible. And then the last thing I'm going to mark are my foci. So remember the foci, in order to find it, I use c squared equals a squared plus b squared. Well, in this case, a, again, is 5. B is 4. So we get 25 plus 16. And I get 41. So c squared equals 41. I'm going to take the square root of both sides, so I get c equals the square root of 41, which is about 6 and, well, what is that? No, not 6. Oh, I did that wrong. It's supposed to be a minus. I wrote that wrong here. When it's in ellipse, it's supposed to be a minus. So when there's a minus sign in the ellipse, then we know that there's supposed to be a minus. My apologies. Please forgive me. This is supposed to be a minus. I'm going to fix that right now. Minus, minus. So 25 minus 16 is 9. And the root of 9 is just 3, which looks a lot better than it did. So we go over 1, 2, 3, and that's the foci. And then 3 to the other side, that's also the foci. So that is our total graph. Our vertices are at right here and here, and that tells me they're at 5, 0 and negative 5, 0. Co-vertices are here and here. We know those points are at 0, 4 and 0, negative 4. And our foci are here and here, which tells me that that is at 3, 0 and negative 3, 0. And there is our graph of our ellipse. I know there's a lot of little pieces in there, but once you get the basics down, the major axis of A, the minor axis of B, and the center, you've got everything you need. Okay, so this next one, write an equation for the ellipse that has a vertex of 0, 4. So here's our vertex of 0, 4. We know that that's going to be the top of the ellipse at the major axes, okay? And a co-vertex at negative 3, 0. So here's the thing. I know that the center is also at 0, 0. So here's what they're telling me. We don't know the rest of this, but we know this distance is A and this distance is B. So we say A is 4 and B we know we can count is 3. So if this is the center here, I know I can copy this length of A down, and that will give me my total major axis. So here is my other vertex, and this will be, if this is 3, then this is 3 over here. This is my other co-vertex. So we're going to label these away. So they gave us, this was the vertex, this was the co-vertex, and right here was the center. So from right there, as long as I have the vertex and the co-vertex, we have the ellipse. But now we need to write an equation for that. So remember, this is a vertical ellipse. A vertical ellipse looks like x squared minus h squared y minus k squared all over it. Now, if this is true, then the a value goes under the y and the b value goes under the x, because the a value is longer and the major axis is on the y axis. So that's why it goes under the y, and then equals 1. So here's what we're going to do. We're going to plug these in where we need to. So we've got A is 4, B is 3, and H and K are the center of 0, 0, which if I add 0 or subtract 0 from x, I'm just going to get x again. But I can write it x minus 0 squared all over B, which is 3 squared, and then y minus k, which is 0 squared all over A squared is 4. So if I simplify this, I get x squared over 9 plus y squared over 16 equals 1. And there is my graph that I drew so that I could identify what is what to write the equation. Now, what if I write an equation for the ellipse with the foci at 1, 2 and 7, 2? So these are foci at 1, 2, and 7, 2. I've already graphed it for you. And co-vertices, so this is a co-vertice here and here. Do yourself a favor and always, always label. Well, here's what we know. We know that the center has to be right in the middle of all of this. So if this is my foci and here's my co-vertices right here, right in the middle of all of it, that is my center, which in this case is 4, 2. So if the center is 4, 2, that's the HK, okay? Now, I know that from the co-vertice to the center, that length is B. So in this case, we go up 1, 2, that B equals 2. So we've got the center, HK equals 4, 2. B is 2, and we don't know A, but we do know the distance between the center and the foci, which is 3. So we know the distance is 3. We do have a formula that's going to relate A, B, and C, where we know C squared equals A squared minus B squared. So we can find A using this. So C is 3. A we don't know, that's what we're looking for. And B is 2. So we get 9 equals A squared minus 4. Add 4 to both sides, and I get 13. Take the root of both sides, and we get A equals the root of 13. Now, the root of 13 isn't a really pretty number, but it's doable. And the root of 13 is going to be bigger than the root of 9, which is 3, and smaller than 4. So it's somewhere in the middle of there. If you plug this into your calculator, you'll be able to find it. So it's a little bit past 3, but not quite 4. So we're going to call it right here, that this distance here is the root of 13, and this distance here is the root of 13. So here's what we know. Oh, and actually back up. Hold on. If we go one step back here, remember how this said 13 squared equals 8? That's amazing because that's all we really need to know. So if I plug this in and I know that this is my vertice in red, co-vertices up here, this is a horizontal ellipse. So I know if it's a horizontal ellipse, I'm going to be plugging it into x minus h squared over a squared plus y minus k squared over b squared equals 1. And remember, again, that's because once we know where the major axis is, if it's in the horizontal direction, we know that the big number, which is a, goes under the x. So let's plug in what we've got. We've got x minus h, which is 4, all over a squared. Now, here's the thing. I didn't need to know the value of 13 yet. I just need to know what a squared is, which I already know it's 13. I didn't even have to simplify it. And then y minus k, which is 2, all over b squared, which is 2 squared equals 1. So if I want to simplify this, I get x minus 4 squared over 13 plus y minus 2 squared all over 4 equals 1. All right, and that's it for today. I'll see you in